have you ever really stopped to think about the road you're driving on? I mean, it just seems like a simple strip of asphalt, right? But underneath that surface, there's a whole world of sophisticated engineering, a system designed to solve really complex problems, and, most importantly, to keep you safe. So let's dive into this hidden world. So here's our roadmap. We're going to break down the 5 biggest challenges road designers face and the absolutely brilliant solutions they've come up with. We'll look at how they manage our speed, how they actually build the road itself, how they plan for crashes, how they fight off rainwater, and all the final details that make a huge difference. First up, and this might be the biggest puzzle of all for any road engineer, is us. It's human behavior. Specifically, how fast we choose to drive. And trust me, it's not as simple as just putting up a speed limit sign. To solve this puzzle, engineers have to juggle 3 completely different concepts of speed. You're definitely familiar with one of them, but what about the other 2? And how do they all work together to keep things safe? Okay, this is where it gets really interesting. You've got the posted speed, that's the legal limit, the number on the sign. Then there's the design speed. Think of that as the engineer's number. It's the theoretical speed they use to figure out how sharp a curve can be. But the operating speed? Well, that's the most human one. It's how fast the road feels, the speed you naturally settle into without even thinking. So the ultimate goal, the real sweet spot in road design, is to make these 3 speeds match. When the road's curves and width make the legal posted speed also feel like the most comfortable operating speed, that's when you've got a truly safe and intuitive system. All right, so once we've thought about speed, we have to actually build the road. So let's take a look at how it's all put together, piece by piece. So at its most basic, if you sliced a road in half, this is what you'd see. You've got your traffic lanes, usually about 3.5 meters wide. Then the shoulders, which give the pavement support and give you a place to pull over. The verges are those clear zones for safety and utilities, and the batters are just the slopes that connect the road back to the natural landscape. And, of course, you've always got to have drainage. But let's be honest, modern roads are way more complex. We start adding layers. We put in medians to separate traffic going in opposite directions. We add safety barriers. We carve out dedicated lanes for cyclists, about 2 meters wide, and wider shared paths for people walking, maybe 3 meters wide. And of course, we need room for parking. Each layer adds a bit of complexity, but it serves a vital purpose for a different user. You know, no matter how well a road is designed, we're human. Mistakes happen. So the next big challenge for engineers is to plan for the worst-case scenario. They have to design systems that can soften the blow when things do go wrong. And this is exactly where safety barriers come in. These are not just concrete walls. They are incredibly precise engineered systems. A common one you might see, a MASH TL4 barrier, stands about 1.2 meters tall. Its entire job is to absorb the energy from a crash and redirect a vehicle, preventing a much more serious accident, like a rollover or a head-on collision. But at the end of the day, the best philosophy is just prevention. By using things like medians and barriers to physically separate cars from other cars, and especially cars from people, we can eliminate the potential for some of the most dangerous kinds of collisions right from the start. Now for one of my absolute favorite parts. A piece of hidden engineering genius that you have driven over thousands of times and probably never even noticed. It solves one of the most dangerous problems on any road: water. I mean, think about it. When there's a huge downpour, massive amounts of water are falling on the road, but the surface looks almost perfectly flat. So how does it get rid of all that water so quickly without creating giant, dangerous puddles? Well, the answer is called road crowning. It's this incredibly subtle arch, almost invisible to the naked eye, where the center of the road is just slightly higher than the edges. This tiny little slope is all it takes to put gravity to work. And this shows you just how powerful that simple idea is. On a road that's totally flat, water has to travel a really long diagonal path to drain off, which creates that dangerous film of water that can make you hydroplane. But with a crown, the path to the edge of the road becomes much, much shorter. So how much shorter are we talking? Well, on a similar road that isn't crowned, water might have to travel 95 meters to drain. But with a crown, that path is cut almost in half, down to just 52 meters. That means water gets off the road nearly twice as fast, which dramatically improves your safety in the rain. It's a simple, elegant, and totally life-saving solution. This incredible attention to detail isn't just for drainage. That same level of precision is applied to every single element of the roadside, right down to the smallest slopes and edges. Take this number 10%. If the change in slope between the verge, that flat area on the side of the road,
and the batter slope that connects to the terrain is greater than 10%, engineers have to add something called verge rounding. It just smooths the transition, so if a car does happen to leave the road, it's a lot less likely to flip over.
Even the curbs are highly specialized. A barrier curb has a steep vertical face that's designed to stop a car. But a mountable curb has a sloped face, specifically designed so that an emergency vehicle or a maintenance truck can drive right over it if they need to. It's always about choosing the right tool for the job. So as we start to pull all this together, the main thing to remember is that nothing you see on a road is an accident. Every single element, from the width of the lane to the shape of the curb, is a deliberate decision based on physics, on safety, and on human psychology. A road isn't just a surface to drive on. It's an active, sophisticated safety system that's constantly working to guide you, to correct for potential errors, and to protect you from harm. It's problem solving that you can actually see and touch. So, I'll leave you with this final thought. The next time you're behind the wheel, look a little closer. Look for that subtle crown in the middle of the road, the specific shape of the curb, the gentle rounding of a slope. Now that you know the language of the road, what will you notice on your next drive?